This is the last and crucial field season for the NEEM ice core drilling project in northwestern Greenland. The researchers will drill ice cores all the way through the 2.5-kilometer thick ice sheet. The international project, with participants from 14 countries, is led by the Danish Center for Ice and Climate at the Niels Bohr Institute in Copenhagen. Deep down, they are hoping to get ice from the Earth's warm past, when the climate was several degrees warmer than today. We are facing global warming, and knowledge of the climate of the past can help us to predict future climate changes. Kangerlussuaq in Greenland. It is late April 2010, and the first researchers are on their way out onto the ice sheet to drill ice cores through the ice cap. They need to bring food supplies and scientific equipment along on the plane. Everything must be packed very carefully, as it will be rolled out of the aircraft onto the snow at high speed. They will be flown to the ice sheet on one of the US Air Force Hercules aircraft. The Hercules is not a typical airliner. It is a heavy and rugged transport aircraft. The plane weighs 60 tons and can carry 12 tons of cargo. The plane is a special model, equipped with skis to land on the ice. Before departure to the ice sheet, there is a briefing. 12 men and 2 women are going in to open the deserted and frozen camp. It is an experienced group: researchers, engineers, technicians, craftsmen, and a cook. The interior of the plane is very raw. Pipes and wires are exposed along the walls. Passengers sit in the cargo compartment, and there are no amenities such as soft chairs or refreshments on board. It is a 2.5-hour trip with the Hercules from Kangerlussuaq to the NEEM drilling project, North Greenland Eemian ice drilling. The NEEM camp is located at 77 degrees northern latitude, approximately 500 kilometers east of Thule. They are approaching the camp. Only the large, round, 14-meter-high black wooden building, called the Dome, and the top of some red tents can be seen in the middle of the endless white. The landing is especially critical on the first trip of the season, as a thick layer of snow from the past year covers the runway. To make the plane lighter and prevent it from sinking deep into the snow, the cargo is rolled out just after touchdown. They have arrived, and they come to a camp that has been left desolate and deserted for 8 harsh winter months, with utter darkness, violent blizzards, freezing temperatures plunging to -70 degrees Celsius. The buildings are covered by large snowdrifts, and everything is frozen. The temperature is -26 degrees, and some hard days lie ahead.
There's one focus, and that's survival. Pure and simple survival. We need to get shelter, and that means we have to dig out entrances, get into buildings, get out of the wind. We need energy, and that means we have to find a generator, warm it up, get it started so we can get electrical power. That will in turn melt snow so we can get something to drink. When we have these things fixed, heat, shelter, and water, we can start to relax.
They slave away. Already the same evening, just 6 to 7 hours after landing, they have the generator running to provide vital electricity to heat the building, and they can get something warm to drink and eat. The hard work of excavating the camp continues. They have to remove all of the snowdrifts from tent entrances and the garage, so that they can get the tracked vehicles out. The tracked vehicles are essential to the camp. to clear the area so they can move about, and to level the runway for the next flight. And they have to construct new tent buildings for the many researchers who will be arriving in only a few weeks to participate in the project. Another need is solved very practically: the case of outdoor toilets. A deep hole in the snow and seat appears to work.
I now declare the first shitter 2010 for open.
A tent ensures a little privacy, and the flagpole signals that it is occupied. Suddenly, a blizzard arrives. The wind gusts at speeds of 30 knots, almost a gale. But they have to brave the storm and go out and shovel snow into the snow smelter for water. The electronic equipment that is outside must be inspected. The cook also has to brave the storm to get food from the storeroom. But in the underground halls, in the drilling hall and in the laboratories, they can work in peace from the storm. All machinery and laboratory equipment has to be rebuilt and installed and made ready for the new season. And in less than 2 weeks, the new team of researchers will arrive in camp and begin ice core drilling and analysis. Things are in full swing in the drilling hall. The first drilling will clean out the slush that has accumulated in the borehole over winter. It is difficult to get it out of the drill.
Let's just try lifting up. It's coming out.
Suddenly, it comes gushing out. It is made up by ice chips that sank to the bottom of the hole during winter. It must be removed before they can start drilling ice cores.
Looks like it might be it.
It takes 5 days to clean the borehole, and they remove as much as 214 kilos of slush. When they begin to drill ice cores, many hundreds of meters of ice core will need to be stored. This requires storage space.
Well, you can be sure about one thing when you're making a camp or working in a camp like that, and that is, if you let a group of scientists work there, they will eventually run out of space. Boxes will be everywhere and everything would be everywhere. So luckily, a snow cave on the ice sheet in Greenland is an engineering blessing, because if you need space, you go to the wall, you cut a doorway, you make another cave, and then you've solved the problem.
Using a chainsaw, they cut large blocks out of the compact snow and break them loose with a shovel. The blocks of snow are as solid as aerated concrete, so they can withstand being thrown around. They are carried over to the elevator and hoisted up to the surface. And then they are just driven away on a sled. Inside the new ice cave for storing the ice cores, they drill deep holes into the ice wall. These are cooling tunnels.
The temperatures in the snow caves are getting too high, higher than minus 20 degrees centigrade, and that's too hot or too warm for the ice cores. And all this heat is coming from all the electrical appliances that we have. So in order to cool that, we drill these tunnels, and then we take out air with pumps from the cold snow that surrounds everything, and use this cold air to cool our caves.
Finally, a hose is placed in the cooling tunnel, so you can pump cold air into the new storage room. Outside, the blizzard has stopped, and there is an optical phenomenon in the sky. Around the sun are patterns of light with halos and so-called sundogs. The phenomenon is caused by refraction of sunlight when the air is filled with snow and ice crystals. You can see rainbow-colored rings, and at the top, they are spectacularly colorful. But the clear weather and visual delights are short-lived. A plane is due to arrive with 24 new people for work on the ice core drilling and on the analysis of the ice cores. But a dense fog settles, and later followed by blowing snow. So the plane cannot land and is cancelled.
It's an eternal fight between us and the weather. Everything can go wrong, and NEEM can have all kinds of weather in very few days. We can have a blizzard, we can have very low clouds so we cannot see anything, we can have fog, it can be warm, it can be cold, all kinds of things. And all this in combination can frustrate us very much, because we have to be ready for the planes, but many times we have to cancel, and it's deeply frustrating. It's a terrible fight sometimes.
But they get visitors anyway. An American dog sled team on its way across the ice sheet makes a stop in the camp and is welcomed. The plane is cancelled over and over again. Not until 4 days later does the plane manage to get to the NEEM camp. Finally, they can bid the 24 new people welcome. They know each other from the previous drilling seasons, and there are happy reunions on the runway. All while the plane is loaded with cargo to be returned. The engines are kept running, and the plane must be loaded quickly so that it may take off while the weather still holds and before it freezes stuck. And before long, the heavy Hercules aircraft is on its way out onto the runway. But the plane has difficulty getting into the air.
We didn't have the proper time to prepare the skiway, so the snow was both too hard and too soft in places, so it was actually quite wavy. So the snow was soft, and the plane could not pick up enough speed to get airborne.
The plane slides along the runway again and again.
So in this particular incident, they had 7 attempts of takeoff before they got airborne.
After many attempts to get airborne, the plane has spent a lot of fuel, and it needs to be refueled. So the plane has to return to the camp. They decide to remove the cargo to make the plane lighter. The cargo is driven away. And here comes an extra power supply. They are rockets. The rockets are mounted to the side of the plane to give it extra thrust to help it get airborne. The fuel hoses are heavy and stiff in the cold and hard to struggle with. After refueling, they are ready for another attempt. And then, finally, the 7th time they succeed. It is teeming with life in the camp and activity in the underground halls. Now they have finally started drilling the season's first ice cores. Soon, they are even getting ice cores with the maximum length of more than 3 meters.
So, this is 346. So, if it's 1 centimeter per year, that's 346 years.
This corresponds to more than 300 years of ice. Each annual layer in the core can tell in detail about the climate of the past. The year before, they reached a depth of 1,757 meters. Here is ice from the Ice Age. We are 35,000 years back in time. The goal is to go even further back in the Earth's climate, to the Eemian period, approximately 125,000 years ago. This period was warmer than today.
The Eemian period is the warmth between the last two ice ages. And we know that this period was 5 degrees warmer than today in Greenland and about 2 degrees warmer globally. And that means that the Eemian period is nature's own example of the climate we are heading for in the next 2 centuries with global warming from greenhouse gas emissions. We are going there, so why not go back in time to find out what's in store for us when we look back? And the big questions about the Eemian period are, was the climate at that time stable or unstable? Were there sudden changes or was it very gradual changes? How big was the Greenland ice sheet? How was sea level reacting? And how was the interplay between climate and the greenhouse gases? If we know this example from nature, then we have a much better chance of predicting what's going to happen to us in the future.
It is the analysis of the ice cores that can reveal what the climate was like in the warm Eemian period. And in the laboratory hall, they are getting started with the detailed processing of the ice cores. They must be measured. And then the ice cores are cut up. Then the ice core is cut lengthwise and distributed to various research projects where each examines different aspects of the climate of the past. Part of a core is always set aside for the future. The NEEM-project is international, with participants from 14 countries. There are approximately 35 scientists and other professionals in the camp at a time. They are cut off from the rest of the world. This calls for special expertise in camp. Here is the doctor's desk.
Jeg hedder Simon Nielsen. Jeg er feltlæge i NEEM-lejren. Jeg har min almene praksis, og så har jeg min ambulance. Her i tasken der har jeg ilt og en masse stoffer til akut behandling. Jeg har morfin, hvis folk falder ned ad trapper, eller får åbne benbrud, eller andre smertekrævende tilstande. Jeg har bedøvemiddel. Jeg har tilstand til kramper og beroligelse. Jeg har tilstand hjertestop, anafylaktiske reaktioner. Jeg har forskellige hjertemedicin og astmamedicin og en hulens bunke antibiotika. Så har jeg en ildflaske her, hvis der er brug for ilt. Og det er der mange tilstande, der kræver blandt andet højdesyge, som man faktisk godt kan få heroppe. Bagved mig der har jeg en hel masse metalkasser fuld med medicin til brug i almen praksis. Og den er fuld af piller. Der er alt fra graviditetstest til antibiotika og forskellige hormoner, og ja, vi har det hele. Her har vi håndkøbsafdelingen. Det er folk kan bare gå op og tage forskellige slags håndkøbsmedicin og solcreme.
When Simon Nielsen is not sitting in his consultation, he is working here.
Her logger vi iskernerne. Vi pudser dem rene for borvæske, og så måler vi dem op i meget præcise mål af 55 cm, og så skærer vi dem ud i små stykker, og så bliver de sendt videre til videre behandling.
In the hall with the laboratories, the researchers are working in extremely cold conditions. It is -20 to 25 degrees in the underground room. But what is it like to both work in the cold and live in a tent in the middle of the ice?
It is not as cold as people think. It is on the ice sheet. It is actually quite comfortable. In our tent we keep second pairs of boot liners because during work they get all sweaty, and once they're wet they start to freeze to your feet. You don't want that. And therefore we always have a pair drying and a pair to wear. We have this very comfortable sleeping bag. It is designed to be used up to minus 29 degrees. So the thing that we have to make sure of that it is not too warm in this tent.
There are also large tents designed for several people and 2 large dome tents for living that need to be moved. 2 years before, they were built on 2-meter high hills, and now they are 1.5 meters below the surface and half buried in snowdrifts. The canvas is loosened from the plywood floor, and the entire tent is lifted with a large crane. The bunk beds and floor are removed. And then the hole is filled up with snow. The floor is set back down, and the furniture is put back in. Finally, they lower the tent back down over the whole shore. And voila, the tent is ready to be lived in again. The ice core drilling is making terrific progress. Nearly all of the cores have the maximum length of approximately 3.5 meters.
347.
And then they reach a milestone, 2 kilometers depth.
Okay, there's your 2,000 meters right there.
Here's to the other 1,999 meters we drilled before today. This happens to come on a day when drilling is actually going the best it's gone all year. And yesterday we said the same thing, so that's 2 days in a row. So here's to NEEM.
Trevor is most likely right, but I think we should need a pencil mark so he can really, with a millimeter, determine whether it's 2 kilometers or not.
But at 2 kilometers depth, it is still ice from the last ice age. Researchers have estimated that it is possible to find ice from the previous warm period, the Eemian, deeper down in the ice at just this place on the ice sheet. The researchers continue to work, full of hope that they will succeed in getting ice from the Earth's warm past. For knowledge about the climate of the past will help to predict climate changes of the future.